summarizing what I learned building my electrical box. I think it's kind of interesting because I don't see very many videos that really talk about placing all of the electrical components and what's involved. So I hope it's valuable to you. One other little quick addendum to it is after I was all done, I was wondering, how the heck do I weigh this thing? How can I figure out how much it weighs? And so I found a technique for doing that, and I illustrate that using a simple bathroom scale to measure some large object that you really can't hold and stand on the bathroom scale. So hope you enjoy. Okay, now that the electrical box is finished, I wanted to talk about a few of the features of it and what I considered in designing it. First of all, what I did was I created this aluminum frame to hold basically the batteries and the inverter charger. These wheels are temporary. This is just so that I can move it around on the floor here. But the idea of this was to have these cross pieces which could be tightened down using these threaded rods here, and that also held it. These are angle pieces of aluminum along both sides to hold it in place, and on the bottom as well. And then the idea was to have this 2-inch piece along here, which would to which I could mount all of the disconnect switches. This is for the battery, or the alternator, the battery, the inverter. This is the DC distribution bus, which is this fuse box here, the charge controller, and then also photovoltaic. Now each one of these includes a terminal fuse block, which I found was really handy because it saved a lot of space. And then there's a positive bus bar here and a negative bus bar here. Now the orientation of the box, this is right behind the passenger seat. So the door of the van is right here, and it gives me access to these controls over here by opening the van door. And then I also wanted to be able to actually extract this battery fairly easily by unscrewing these bolts and just taking off the top piece, lifting it up slightly, and the bottom piece, and then just sliding the batteries out, disconnecting. They're connected to each other, but there are two connections to the positive bus, one on this side down below here, and then one on the other side. One of the things that I didn't anticipate, which was kind of a design weakness, was how close actually this battery terminal is to the threaded rod. And so what I did was I put some heat shrink on this rod just for extra assurance that this wouldn't jostle loose and come in contact with that threaded rod. I don't think it will. This is pretty solid. One of the things that I found was a difficulty with this system was that it did tend to rack a little bit. And then to avoid that, I put in some extra screws, in various places to keep it from racking, and also another couple of pieces, in between here and in between the batteries to keep them from sliding back and forth. Now, the ventilation for the whole system is a hole, which is basically it's going to be the size of this DC distribution block here down below. All right, so that hole goes through the van floor, and it provides a path for air to come up through here. And then the actual fans on the charger inverter are on this end, so they suck air in from this end. So the air will flow through this thing, around, and then through this inverter out. One thing that occurs to me is that I might want to enclose this with some mesh screen to keep out bugs. But I'll see if that becomes a problem. I'm not sure it will be a problem. One of the things that surprised me, and probably shouldn't have surprised me, is that this thing is friggin' heavy. Oh my gosh. And I've got a little video to show you how I measured how much it weighs, but it's about 120 pounds. So that was one concern after I figured it out, is weight balance in the van, because this is going to be, as I said, this is on the passenger side. Here's the passenger seat right here, and this actually, this threaded rod is 3/8 as opposed to 1/4. The other rods are 1/4, and the reason for that is because this is actually one corner of the bed, and this is one corner of the bed. The bed is over the top of this and extends out through the bed of the van. And so anyway, so the weight, 120 pounds on the passenger side, right beside the passenger seat, had me a little concerned. Now I do have the Dometic refrigerator, which is about 50 pounds on the other side of the van, but you know, this weighs quite a bit more. On the other hand, I'm going to be driving the van most of the time by myself, so my weight is going to be on the driver's side. So maybe it isn't such a big deal. I also have a microwave on this side of the van, which is about 20 pounds, which, you know, wouldn't be ideal. I'd rather have it on the other side to help balance, but it just doesn't work out design-wise. But I do have the rest of my stuff on the other side of the van, you know, the water, the gray water tank, and the propane, and the sink, and the food cabinets with all that kind of stuff. So hopefully that will balance out the weight issue, you know, of having this. But otherwise, I think this is a pretty compact design. It includes everything that I need in one small package. The photovoltaic wires will come down right beside the unit and come in here. The DC distribution and AC distribution will extend across the floor to the other side and to this side. This is the AC breaker here, which is a marine breaker. You can't get a AC breaker that is not a bus type breaker at Home Depot or Lowe's. So you need to order this from a boat supplier, and then you can mount it inside a conventional AC outlet box. So I'm not sure what else to say about this. These are pretty handy. Once you turn it on, I'm not going to turn it on because that would power my positive bus from the back. Well, I suppose I could. Alright, so that's on. Once that's on, you can't extract it. Okay. When it's off, you can pull it out. And the reason for that is if you're doing maintenance, you know, it's a safety issue. So you disconnect the circuit, you put the handle in your pocket, you know that nobody's going to close that switch again. So that's the idea of that. And these, you know, if you're going to be off for a while, you put those caps on. I thought these were a pretty good solution. One thing I would like to say is that you should not operate these DC disconnect switches under load if you can avoid it. Every time you open up a DC breaker, you're drawing an arc across those contacts, and that arc has to be lengthened and cooled in order to extinguish. It's not like an AC circuit where that current goes to zero and then it extinguishes the arc every cycle. In a DC circuit, you basically you extend that. So you're going to draw an arc every time you operate one of those switches. Now, the arc is caused by the current wanting to flow. So if there's no current in the first place, there's going to be no arc. That means that you should try to operate all of these switches when they're de-energized. In other words, like if I'm operating photovoltaic panel over there, what I will do is I'll shade the panel first so that I can minimize the current going through this disconnect switch, and also the charge controller. The battery, I operate the battery switch first. That provides power to the positive bus and the negative bus, but I make sure that these are open before I do that. So that, actually this is the alternator. sorry, this is the alternator switch, this is the battery switch. So the battery switch would be, these would be open, all of these would be open. I would operate these, this one first, this one second, this one third, this one fourth, this one fifth. That's why I placed these this way, so it was easy for me to remember which order that I wanted to operate these switches. So I operate the battery switch first, which powers the bus with no load on it, so there's no current. Then the charge controller is off, so I close this switch, which is, there's no current because it's off. Then I have a remote actually switch from my digital control for this inverter charger, which I can operate to power this. Then I can close the AC switch to energize my AC circuits, and similarly at that point I can close the DC switch to energize my DC breaker box. But as I said, I don't want loads on these things. It's not that they won't interrupt loads, it's just that, every time you interrupt a load with one of these switches, you're drawing an arc, you're creating a little bit of burning. Now they are rated to handle that, but it decreases the lifetime. So, I would just rather operate these switches when they're de-energized as much as possible. So I just try to keep that in mind. But other than that, I think it's a pretty good design. It puts all the stuff in there. I think it's an efficient use of space, and I'm not sure what I would have done differently. I wish that all of these components would occupy less space and weigh less, but it is what it is. So that's my electrical box. This is my finished box, and I'm interested in figuring out how much it weighs, because it seems like it weighs a lot. And the technique here is I support it under the bathroom scale on one corner, and then I have the other corner supported so that they're equal height. I can pass my finger underneath this corner and this corner over here, so I know that I have all the weight between the two of these, and I'll weigh this side of it first, and then I'll weigh the other side. So this side weighs 68 pounds. And this side weighs 53.2 pounds. So the box weighs the sum of those two. So the box weighs in total 121.3 pounds.